Hi, pre-calculus students. Welcome to section 3.4b, solving logarithmic equations. Here is our list of our steps, and here are our example problems. So today we're going to use logarithmic properties first to ensure you have only one single term or one log on each side of the equation. So we may have to use some simplification. Then we're going to exponentiate. I think it's kind of a cool word, each side of the equation. What this means is we are going to identify the base based on the logarithm that we have going on. And we are going to write that base on each side of the equation, writing the sides of the equation as the exponents. So if you remember, when we solved exponential equations, we took the natural log of both sides, and that allowed us to bring the exponents down. So because logarithmic equations are inverses of exponential, this means that we are going to use bases and raise those sides back up. Then we will see some canceling, and we will do our math very carefully. So we're going to make sure we only have one term, one logarithm on each side of the equation. We're going to identify the base that's associated with the log and write those bases on each side of the equation, making the sides the exponent. We're going to be doing some canceling based on our logarithmic properties. We will solve for the variable carefully, and we will check our solutions. In the interest of time, we will not check our solutions here, because the shorter the video, the better, right? I did forget my calculator. I'm going to get it. All right. So on number 18, this problem, when you take a look at it, the natural log of x minus the natural log of 5 is 0. Take a good look at it. What does x have to be for this to be true? The natural log of what minus the natural log of 5 equals 0? Obviously, the answer has got to be 5, right? X has got to be 5, right? That's the only way this is true. Why then did I pick this equation? Just because we need to use logarithmic properties to solve it, and we will show that the answer ends up being 5, okay? So based on the fact, number one, we are only allowed one logarithm on each side of the equation. I see 2 separated by a minus sign. This means I'm going to use the quotient property to write a single logarithm on the left. So that would be the natural log of x divided by 5 equals 0. Right, use the quotient property. Now I'm going to exponentiate both sides. Because I have the natural log, I can see that the base is e. And so I will write the base of e on each side of the equation. Notice I have made the sides the exponent, right? E and the natural log cancel out, and I get x over 5 is left equals e to the 0, which is 1. And notice to solve for x, I'll multiply both sides by 5, and I get x equals 5, just like we had here. Okay, number 22. Log of x equals -2. Notice because the log is written and there is no base, it's the common log, so the base is 10. I have one log and one term on each side. My base is 10. I'm going to exponentiate both sides. The base of 10 and log base 10 cancel out, and I'm left on the left with an x, 10 to the -2. That is 1 over 10 squared, which is 1 over 100. So the answer is either 1 over 100, or you could write it as a decimal. Let's try something a little harder. This is a 2.1 here. Notice that I have one term and one log on each side of the equation. I see that my base is e due to the natural log. I'm going to exponentiate both sides. Okay, that causes e and the natural log to cancel. On the left, I'm actually going to put that value in my calculator, which is why I grabbed it. That is e. Let me find my e button, to the 2.1. I'm going to round to the third place. That's 8.167 equals 6x. And I will divide both sides by 6. And x equals 1.361. That's a 3. There we go. If you put into our original equation 1.361 here, times it by 6, took the natural log, you would get really close to 2.1, maybe off a little bit due to rounding. Okay. Number 92, we have one term and one log on each side of our equation. There's a couple ways to solve this problem. But I think what you would most likely naturally do is you would see that you have a base of e. So you would exponentiate both sides with a base of e. The e and the natural log cancel out, and you have the square root of x minus 8 equals e to the 5th. I'll get that in my calculator. 148.413. I will square both sides to remove the square root. And I get x minus 8 equals 148. This is going to be a big number. Sometimes when you get big numbers, you think you did something wrong, when in fact you did not. 22,026.466. And we will add an 8 to that. And we get x equals, when I add an 8 to that, might as well not attempt, might as well just put it in the calculator since it's already in my hand. There we go. If you put this large number in right here for x, subtract 8, take the square root, take the natural log, you will in fact get very close to 5. So that is 3.4b. I hope you have a great day.